Volume deals with the amount of space an object contains. Now, surface area is only the outside, right? So the surface area of this thing that I am holding is that circle, and once around to the paper towel, right? Everybody with me? That's it. 2 dimensions, 2 dimensions, 2 dimensions. Area is always 2 dimensions because it's only length and width. Yeah? I hate it when people do that. I probably did that. Volume, however, is everything. All the space in the universe that this thing takes up. If this thing were to miraculously disappear, all this space would need to be filled. Okay? So it is 3 dimensions. It's length, width, and depth. Okay? So you got to remember that volume is units cubed. Why? Because you have this unit, and this unit. They're all multiplied by each other, so it's cubed. So it is 3 dimensions. Now there's some tricks to that, and we're going to talk about them in a second. But the first thing we got to talk about is what exactly it means. Now remember, we have prisms and we have pyramids. Now, a prism is really, really easy. Okay? Every prism's volume of every prism equals, now, the math is easy, the thinking is difficult. It's the base area times the height. Now, remember we talked yesterday, why is the word base a loaded word? Why is that complicated? Sydney. It's not always the bottom. What is the other meaning of the word base? Go ahead. The starting shape, right? So every prism starts with one shape. What shape does this prism start with? A rectangle. If I stack 250 rectangles on top of each other, what do I get? I get one prism, right? This shape starts with what? A circle. If I stack infinite circles on top of each other, what do I get? A cylinder. So if I know this area and I multiply it by however many times I stack it, I get the volume of this shape. Understand? Here's where you guys get screwed up. When I take a shape like this and I lie it down. Because your book says base area times the height. And as soon as we math teachers lie something down, everybody wants this to be the height. All right? So the base area, the base is the shape that repeats. And what do I mean by that? In this rectangular prism, it is this shape that repeats going that way. Everybody cool? In a cylinder, it's that circle shape that repeats going that way. Okay? Now, here's the thing. If something happens once in math, it always happens. That's why math, even though it seems to not make sense, it really does. There's rules in math. What would it mean if I gave you this shape? You don't have to draw this, just think about it. How would you tell me the volume of that? There's no formula. Well, there is a formula for it, but you don't know it. What would you do if I wanted the volume of that weird shape? Brooklyn? You would find this area, whatever it is, however you could, and then what? Then you'd multiply that red by this. Cool? Everybody understand? Doesn't matter what the shape looks like. So if I gave you something like this, if you could find this area and then multiply it by how far back you went, you'd be cool. Everybody understand? Doesn't matter what the shape is. Now, how do you do that? Well, that shape there is just two rectangles, isn't it? Everybody picking up what I'm putting down? Okay, so we're cool with prisms. They all follow this rule. Circles, octagonal prisms, tetrahedron prisms. They all follow that rule. If you can find the area of the shape that repeats, you can always find the volume. Okay? Sometimes you got to put two shapes together to figure it out. Pyramids are slightly different. And I'm going to use this as my example because a cylinder and a cone are prisms, right? So right now this is a cylinder. It's got a shape that repeats, right? If I told you that I want the volume, you would all do pi r squared here multiplied by this, right? Everybody's happy with that. What if it's a cone? What changes in this if I turn it into a cone? I shouldn't say that. What would be the same if I have this and a cone right beside it? Pardon? The base, the circle would stay the same, right? But a cone comes to a point, yes? So we would lose all this space out here, wouldn't we? Right? So through experimentation, mathematicians back in the day found out that all pyramids, their volume, and I'm going to use blue for that, not red, their volume is the same as a prism. It's still base area. It's still base area times height. Is that slant height or height? Still regular height. But they are always divided by 3. Always. Now, your book, that sheet I gave you, writes this differently. That sheet I gave you writes it as 1/3 base area times height. But you guys need to be aware by this point in your math careers that multiplying by 1/3 is the same as dividing by 3. Everyone knows that, right? I like to write it this way because it's tidier. And because, like you, I once hated fractions. But now I'm friends with them. We've gotten along. We've gone out for coffee a few times, and everything's all right. But we've decided that we can't date. We're better as friends. Nothing? Screw you guys! It's good comedy. I'm just kidding. Don't. Right? I love you all. I barely met you. Everybody cool? Yeah. All right. So there's only 4 questions. I took one out. Calculate the volume of each object. So we're going to go back to the previous surface areas that we've done. And you don't need a lot of room because you won't have a lot of room. So I'm going to block this off with a purple box. We're at the Matteos question on page 27. So I want the volume of my Matteos box. So rectangles are the easiest ones because all the base shapes are the same, right? It could be this green rectangle repeated back 8 times. It could be this yellow rectangle repeated across here 24 times. Or it could be the blue rectangle repeated down here 40 times, right? All 3 are fine. So because it's like that, the volume of a rectangular prism is usually written as LWH, length times width times height. And if you look on your sheet, indeed, they give you just that. HLW. Doesn't matter how you draw it. Okay? So you guys go ahead and punch that in to your calculator. 40, 24, 8, and you get 320 times 24 is 1280, and 6400 is 7680, right? 7680 watts. Centimeters squared. Why is it cubed? Because it's volume. Now, guys, I am not your middle school teacher. When you forget that little cubed, I do not mark the whole thing wrong. Okay? I pleasantly remind you that you might need to lose a half mark, right? But again, I'm much more concerned with the math part of it. Okay? So don't get stressed. Let's go to the next one. The next one was the pyramid. Now again, you don't need a lot of room because pyramids are what? Volume of a pyramid. I'm going to get my purple box right here. Pyramids are all base area times height divided by 3. So it's the base area of our pyramid. It's 32 by 32, right? So 32 by 32. What was our height? By 65, all divided by 3. I cannot do that in my head. I have to go to my calculator for that one. You guys could tell me while I get my calculator going, though. What is it? What is it? 22,186.67 feet cubed. Thank you, David, for not going 22186. Thank you for giving me a real number in a math class. It was you that said 22,000, right? And also thank you for taking credit. And thank the rest of you for not saying, no, it was me. Okay, what about the next one? What's a cone? Pyramid or prism? Pyramid. So it's base area times height divided by 3, right? So I'll get my purple box here. It's again, volume equals base area times height divided by 3. But this one's weird because the base is what? It's a circle. So we got to do pi r squared times height divided by 3. We knew the r was 15. So it's pi times 15 squared. We knew our height was 22, wasn't it? 22. And then we divide the whole thing by 3. And depending on how your calculator works, you could have you could have 1650 pi, or you have what? 6.3. Do I care which one you show me? No. I couldn't care less. Some people are happier with this, but I will warn you again, the further you go in math class, the more often you're going to end up leaving the answer as pi. Everybody cool? Volume's pretty easy. Cylinder. Is a cylinder a prism or a cone? Prism. So there's no divide by 3, right? It's just base area times height. Oops, not divided by 3. But the base area is pi r squared times height, pi. Our r was 5 squared, and our height was 20. So it's 500 pi, or 1570.8. Is everybody cool with volume? There's not a real trick to it. But before I let you go with work on this stuff, we're going to talk about 2 other shapes in a second. But before I do any of that, I want you don't need to write this down. I want you to look at what I'm doing and think about it, okay? You don't have to write anything down. You can just think about it. You can talk to your neighbor about how you would solve it, but I want to take some time to show you some weird stuff here. For example, this. Pretend I drew that perfectly. Everything's square and nice and 90 degrees. How would you tell me the surface area of that? Again, you don't have to write it down. You just got to think about it. Surface area, not volume. Nobody would like to volunteer what they would do? Sydney? Okay, so you would find this surface area of this guy that I've labeled in red and this guy that I've labeled in blue, and then you would take away what? Right, you'd take away this right in here, correct? How many times would you take that away? Twice. Of course it's twice. And we all know that, right? What's the surface area of this? It's one hand, right? What's the surface area of this? One hand. But if I put them together, I lose half of that surface area, correct? Because it's covered, because surface area is exposed. So you've got to remember that. This is called a composite shape. You don't have to write this down, but if you want to, you can. Composite shapes, you must subtract 2 overlaps for surface area. What about volume? Is there any subtraction? No, there isn't, because it's the amount of space that's inside the object, right? So there's all this space and all this space. Volume has no subtractions. So how would you go about finding the volume of this piece? What would you do? What if I told you this was 4 and these two were the same? That was 8 and that was 6. Could you do that now? What would you do? Is it a prism? Is it one shape repeated over and over and over? Yeah, it's this shape repeated 6 times, isn't it? So if you could find that area, you could find the volume. Everybody cool with that? And of course, the area of that, it's just 2 rectangles, right? Everybody cool? Okay. Let us finish off our volume bit. Back to, we are still on page 33. So we've covered prisms, we've covered pyramids. The next thing we got to cover are spheres. Now, spheres are weird because you can't draw them, right? You can always origami every other prism and cone and pyramid, but you can't do that with a sphere. There's no way to draw it because it can't be drawn flat because it's got no edges, right? So I just give you the formulas. How did they come up with the formulas? Experimentation. They took cubes, turned them into spheres, and then measured their volumes and radii and things like that. That's how these formulas came about. So the hardest one I find to use, surface area is easy peasy. I find this one really hard to use because I don't like the way it's drawn, the way we write it. This is how it's always written. I like to write this as 4 pi r cubed, all divided by 3. I find that's easier to work with. So what you do is you use your calculator to find the top. You can either put it in brackets or hit equals, and then afterwards you do divided by 3. I find that the easiest way to do it. So let's have a look at this question. Amber plans to wrap a basketball as a present for her brother. First of all, that's doofus-like. You would never wrap a ball. It would be in a box, right? So you'd be wrapping a cube. But math guys like to write questions like this. So I did. It's also not much of a surprise when you hand someone that. My wife got me a steering wheel cover as one of my birthday presents this year. She handed it to me, and my buddy would say, hey, I want a steering wheel cover too. And it was still wrapped. He knew what it was because she wrapped it actually all the way around, like a round thing. I don't know why. So Amber's going to wrap this basketball as a present for her brother. She finds that the ball requires that much wrapping paper. What's the radius of the ball? So this question is doing double duty. It is making you use surface area or volume, and it's going to make you do some algebra. First of all, which one am I going to be doing? Surface area or volume for wrapping up a basketball? Surface area, of course, because it's only the outside, right? We don't care how big it is. If I was wrapping a bowling ball, it would still be surface area. So we know we need this formula. Surface area equals 4 pi r squared. Now I'm going to use this question to do 2 things. 1, discuss surface area, which we just did. And 2, I'm going to use it to practice your algebra. What do I know in this formula right now? And what is unknown? I know the surface area. So what can I write there instead of SA? 2,500 equals 4 pi r squared. I don't know r, do I? Okay, now you guys figure out r. It's a test to see how many people remember their algebra. And it's a double test because I gotta pee. So I'll be back in a minute. Figure that out. You'll need your calculators. My key doesn't work for the staff bathroom. I don't think they want me using it. I walk all the way down the hall. So what's the answer here? 14 point. That sounds about right. Here's the problem. I assume that most of you knew you had to divide by 4 pi to get r by itself. Most kids forget to bring pi over because they think it's an unknown, because it looks like a variable, right? But pi is not a variable. Pi is a number, isn't it? And then, of course, you had to square root 2,500 divided by 4 pi. Now, if you didn't get 14.1, but you did the math right, that's probably because you're not so hot with your calculators. And that's okay. All right. Is there anybody that needs to be shown how to do that with their calculator? Or did everybody get 14.1? Everyone's cool? Okay, good. Usually I have to remind people the calculator stuff there. All right, let's look at 34. 3 golf balls into a cardboard box. If the balls fit snugly against the sides of the box, find the volume of the box that remains as empty space. So, I got a box with 3 golf balls in it. I got to find the empty space. So what's actually happening here? I have the volume of a prism, and I'm taking out the volume of what? Each golf ball, right? How many golf balls are there? 3. So it's the volume of one prism minus 3 volumes of the sphere. Yes? So, how do I find the volume of the prism? That's length times width times height. So it's 3, 3, 9. That's easy. LWH minus 3 spheres. 4 pi r cubed over 3. Now when I write it out like that, it becomes really easy. What do I get to do with this 3 and this 3? Cancel them out, because 3 divided by 3 is 1. So what I really have is LWH minus 4 pi r cubed. LWH is real easy. 3 times 9 minus 4 pi. What's r? Because this always messes people up when I give this question. What's r? 1.5. And then you just punch that into your calculator. Now again, I remind you, if you get to here and the question is out of 3, and you do everything right to there, you're still getting 2 out of 3. Because this isn't calculator 10, right? Everybody with me? And you're going to punch that into your calculator, and the answer is going to be 81 minus... I can't do that one in my head. (13.5 pi). Then you could leave it like that, or you could actually do the work. And what do you get? Everybody good? I think that's it. All right, so break time for you guys is... Where's my sheet? Can't remember. It's coming up. It's very soon. When is it? It's 9:15? I thought it was 9. Regardless, work on 35 to 38 until break. When you come back from your break, quiz, then I'll give you some more time to finish 35 to 38. Oh, and also you have time to work on this if you want as well. 30 to 32. So by second break today, I want 30 to 32 done, and I want 35 to 38 done. by second break today. Okay? So we're about to have a first break. Then you're going to write a quiz, which is very short. Then I'm going to give you some more work time. Cool? Okay. I'm going to pause. Okay, guys. Just while you're settling down, I'm just started recording this key here for you. You already saw this one. We talked about that. You already saw this one. We talked about that. So I'm just going to move on, finish recording up this couple of keys for you guys. Now, page 31, E and F. I've used colors to try and help. So, actually, it's probably easier if I just sit down here. So you will notice that in this one, I need this yellow rectangle and the yellow rectangle that's right on the front, correct? So I highlighted them yellow. This one's easy, 3 by 4. This one up here is 3 by 5. How did I get the 5? I did Pythagoras, 4 and 3 right there. 25 or 16 plus 9 is 25, square root of 25 is 5. So there is the yellow parts. The green part is 4 is my base, 3 is my height, and divided by 2, but there's 2 of them, so the 2's cancel, so I got 12. Is everybody okay with the triangle part? Okay, now I come over to here, and before I do any math, I look at it and I say, what do I need? Well, that top, I know there's 2 of them, and it's 8 by 3, and there's 2 of them, so I did that in orange. It shows up as red up there. I look at this, and I know there's 2 of them. 8 by 3 again. There it is in blue. This purple one, though, there's only one of them, isn't there? Because the other side's covered up. So I only did that times 1, and then I just add it all up. Is everybody cool? Okay, please notice how much thinking I'm doing before I even write down a number, right? Over here, I'm going to do the same thing. I got 2 roofs. Well, that's easy, 5 by 15. There they are, and there's 2 of them. I got 2 walls. Well, that's easy, 15 by 2, and there's 2 of them. I got 2 front and back rectangles, 8 by 2, and there's 2 of them. Then I got to think, oh, but there's also the bottom, but there's only 1 of them. 15 by 8 right there, which is why it's not colored. And then this triangle, 5 by 5. Base times height, because if I turn this 90-degree triangle this way, 5 and 5, there's a base and there's a height, right? Because I had that 90-degree there. And then there's 2 of them, so cancel the 2's, it's 25, then you just add it up. Everybody cool? Now this one I like to spend a bit of time with. Because again, most of you guys probably split this right here and did the surface area of that one, and minus overlaps, correct? But I like to look at this way. Isn't this shape right here? What if I did this? Wait a sec. You could all do that one super easily, couldn't you? Okay, what's the only thing that's missing? Just that little rectangle right here is gone from the whole thing, isn't it? So if I find what that rectangle is, which happens to be 11 by 2, and I multiply it by 2 because it's also missing over here, then can't I just find the whole surface area and take away 44? Everybody picking up what I'm putting down? You could do it with surface area 1, surface area 2 minus the overlaps. No problem. You're going to get the same answer. But if you stop for a second and think about it, you can do a lot of this work before you ever do any work. Is everybody with me? And let me show you what I mean again. I'll draw it a different way that often helps. That green roof and that green roof didn't disappear, did they? That pink and that pink are the same as this backside over here, aren't they? Right? And this blue is on the back, and you could carry it on out here. The only thing that's missing is that 22 twice. Everybody with me? It all comes down to thinking about what you're doing rather than trying to follow formulas. But let's say you're not very good at thinking about what you're doing. Can you still get by just following the formulas? Of course you can. Everybody cool? Okay. This one was pretty easy. It was just filling in the formula. It was either 66 pi or 207. Now this one was tricky because I gave you the paint covered square feet, but I gave you measurements in meters. So you had to convert them. Technically, I could give just this single question as your whole unit test, couldn't I? Because it makes you do conversions and surface area. It's like my favorite question in this whole unit. So it came out to 606 feet. 1 gallon will do 300, but you got to buy it by the gallon, so you had to buy 3 gallons. What usually trips people up on this is they don't think somebody always does 4.1 by 5.3 to find an area there. But these are the walls. That's the floor. The walls are 3 meters high. You're only painting the walls. So every wall looks like this. There's 2 walls that are 3 meters tall, 4.1, and there's another 2 walls that are 3 meters tall and 5.3. So that's what I did. I changed them to feet, multiplied by 2 because there's 2 of them, and then realized I needed 3 gallons of paint. Cool? Okay, that is test level question, not quiz level. You follow me? Tomorrow when I give you a quiz on this stuff, a question that hard would not be on it. But by Friday, I could put something like that on. Everybody okay? All right. That's it. Now, these I'm going to do in a bit. Okay? We're going to go on to this page, which is page 39, please. Oops. We're going to do 39 together, but not really. Okay? So here's what I want you guys to do. We're going to go a question at a time. So we're going to work on number 1 as a group. So move around, talk to somebody, see if you can figure out how to do this question. Okay, I'm going to stop my recording.